Okay, fourth graders, as discussed, we are again combining two lessons, Module 5, Lesson 26 and 27. Today our main goal is going to be comparing fractions that are greater than 1. The good news to you is that we've already done this work before. We've compared fractions before, but the only difference is today we're going to be comparing fractions that are bigger than 1. We're going to be using all the same strategies we've used before to compare fractions. We're going to be using benchmark numbers. What are some benchmark numbers? Like 0, 1, and everyone? 1/2, good. Sometimes we'll be using benchmark numbers. Sometimes we'll be making common numerators. Remember, numerator is the top number in a fraction. If we have the same numerator, can we tell which one is bigger? Yeah. And the third strategy we're going to be using is using common denominators. That's the bottom number. Okay. If we have the same denominator, we can also easily compare to see which one is bigger. So we have 3 different tools in our toolkit for how to compare fractions. We've used all 3 before. The only difference today is that our fractions will be larger than 1. The question is asking us to plot the following points on the number line without measuring. You can see that our number line goes from 2 to 3 to 4. Go ahead and draw yourself a number line going across your whole page, going from 2 to 3 to 4. Now, it's asking us not to measure. Okay. What's right in the middle of 2 and 3? What's right in the middle between 2 and 3? Everyone? What? 1/2 is in between 2 and 3? 2.5. Good. What's right in the middle of 3 and 4? 3.5. Good. So let's talk about the first number, 2 1/6. Now that we have our benchmarks. 2 1/6 is pretty close to what number? 2. Is it going to be more or less than 2.5? How many sixths would be 2.5? Everyone? 2 and 3/6. But we only have 2 1/6 here. So we can mark it close to 2 and mark that that's 2 1/6. The important thing for you to note is that it is not more than 2.5 because we're using benchmarks. Okay, let's talk about the next one, 3 3/4. 3 3/4. How does that relate to 3? Greater than or less than? Okay, how does it relate to 4? So we know it's going to be somewhere between 3 and 4. How does it relate to 3.5? Everyone? It's greater than. In fact, it should be exactly halfway. So using benchmarks, we can mark that 3 3/4 is right there. Okay, our last example is 33/9. This is an improper fraction. Whenever you see improper fractions, it helps us if we can convert it into a mixed number. How many ninths does it take to make one whole? 9. How many ninths do we have here? Sorry, how many copies of 9 ninths do we have here? Let's skip count by 9. Ready? Go.
9, 18,
27, and then?
36.
Do we have 36 ninths? No. But we do have 27, so how many holes do we have? 3 holes. And then how many ninths are left? 6 ninths. What do we know about 6 ninths? Is that more or less than half? Huh? So is that greater or less than 3 1/2? Greater than. Okay. Could I decompose it or compose it to make it into a simpler form? 3 6/9 is the same as 3 2/3. So how does that compare to 3 3/4? Because we have to figure out, should we put it on this side or this side, right? What's more, 2/3 or 3/4? How can we figure that out? Talk at your table groups. Now that we have the number line, we can use the number line to help us compare the fractions. How does 33/9 compare to 2 1/6? Look on your number line. Is it greater than, less than, or equal to? Everyone? Please write the whole number sentence. 33/9 is greater than 2 1/6 under your number line. How does 33/9 compare to 3 3/4? Everyone? It is less than. Good. Go ahead and write that. So again, you need to work on making sure that you think about benchmark numbers and thinking about, in this case, when we were comparing these two numbers, we were using the benchmark number of 4. We were thinking, how much distance is there to get to the next benchmark number? And that can help us figure out which one is bigger. Okay? This is an area where lots of you need work. Okay? Now, this time we're asked to compare these fractions. Okay, we don't have a number line this time. It's asking us, again, to think about benchmark numbers. Okay, so let's use that skill. If we have 5 and 1/3, how much would I have to add to 5 and 1/3 to make it get to the next whole number, which is 6? What do I have to add to that? 2/3, right? Okay. Now, what about 5 and 3/4? What do I have to add to that to get it to the next benchmark number, which is 6? 1/4. What is bigger, 2/3 or 1/4? 2/3. That means that this one, if we think of it as a number line, here's 6. That means that 5 and 1/3 is 2/3 away from the next whole number, but 5 and 3/4 is only 1/4 away, right? So because 2/3 is a greater distance, 5 and 3/4, which number is bigger? Which number is bigger? Everyone? So how does 5 and 1/3 compare to 5 and 3/4? It is less than. Do you see how we are using the benchmark number of 6 to judge how far away from it we are, which would tell us which number is bigger? Okay. Let's try the next example. We have 12/4 and 25/8. What do you notice about both of these fractions? They are improper. When they are improper, we have to first convert them to be mixed numbers. That will help us a lot more. 12/4. How many fourths does it take to make one whole? Everyone? So how many holes do we have here? 3. Good. 25/8. How many eighths does it take to make one whole? 8. So how many holes do we have here? 3. And what's left over? 1/8. Right when we convert it into whole numbers or mixed numbers, we can see the relationship between these two numbers, can't we? Obviously, 3 and 1/8 is greater than 3, so 3 is less than 3 and 1/8. So sometimes all you need to do is convert it into a mixed number, and then you can see how the two numbers relate. This problem is asking us to draw a tape diagram to model the comparison. Okay, so for our first example, we have 2 and 3/4. So I'm going to show that I have 2 here. Oops, sorry, this is 1, and this 2. And then for this one, I'm going to divide it into 3/4. So 2 and 3/4 would be 1 hole, 2 holes, and 3 of these fourths. Do you guys see how I did that, right? Okay, do you guys see that? Then for the second one, I have 2, so I still have 1, 2, and then instead of fourths, I have eighths. So I'm going to make eighths, and then I'm going to color in 1 hole, 2 hole, and then, is that 7/8? There we go. Okay. Then for my first example, if I use my tape diagram, I can see that 2 and 3/4 is really the same as 2 and 6/8. Do you guys see that? And over here, this is 7/8. So using my tape diagram, I can see that 2 and 3/4, or 2 and 6/8, is less than 2 and 7/8. Did we really need to pay attention to the 2 part? Do we really have to compare that? No, because we know that 2 is equal to 2. So we really were just focused on 3/4 and how it compares to 7/8. Do you guys agree? Now, for the second example, we have 10 and 2/6 and 10 and 1/3. What do we know about the whole number parts? They're the same. So really, all we need to compare is 2/6 to 1/3. So let's draw a tape diagram to show 2/6. So I'm going to have 1 hole, and I'm going to divide it into sixths. And I'm going to shade in 2 of those sixths. Then my second one is 1/3. I'm going to draw a hole. I'm going to divide it into thirds. And I'm going to shade in 1 of the thirds. Could I decompose my thirds to become sixths? Yeah. When I do that, what do I notice about 2/6 compared to 1/3? It is, so 10 and 2/6 must be equal to 10 and 1/3. Again, if your whole numbers are the same, then you just pay attention to the fractions. This is a reminder of how we can draw tape diagrams to decompose or compose fractions to make them equivalent. To draw area models are just like tape diagrams, except your lines go horizontal and vertical. Okay? We want to make like units, then use greater than, less than, or equal to compare. So go ahead and copy the first problem. 2 and 4/5 compared to 11/4. What do you notice about 2 and 4/5? That's a mixed number. 11/4 is a, so let's properize it first. We want them to either both be improper fractions or both be mixed numbers. In most cases, mixed numbers will be easier because you can compare the whole number part and then you can compare the fraction part. How many fourths does it take to make one whole? So how many wholes do we have here? 2. How many fourths did we use up when we took out 2 wholes? 8/4. How many fourths are left? 3/4. So when we turn it into a mixed number, you can see that we're really comparing 2 and 4/5 compared to 2 and 3/4. Well, when we did that, we can see that our whole number part is the same, 2 and 2, right? So really, we just need to compare 4/5 and 3/4. Do you guys agree? Okay, so if I want to compare 4/5, I have to make like units. So let me show 4/5 first. I'm going to divide using vertical lines my area model into fifths, and I'm going to shade in 4 of them. Right? And then for my next area model, I'm going to show fourths, but I'm going to make them go the other way. I'm going to divide my whole into fourths, and I'm going to shade in how many of them? 3. Good. Okay. Now, if I overlap those lines, I'm going to draw my 4th lines over here and my 5th lines over here. When I do that, I can show that 4/5 is equal to, how many units does one whole have now? I have 5 going across and 4 going down. How many units do I have? 20. And how many of them are shaded in? 16. 4/5 is equal to 16/20. Over here, I had 3/4 before. Do I also have 20? I have 5 going across and 4 going down. Is that 20?
Yeah.
How many are shaded in?
15.
How many? 15. So I'm really comparing now 2, if I make like units, 2 and 16/20 compared to 2 and 15/20. Can we compare it now? Yeah. What sign should we use to finish this, to fill in the blank? Everyone? Greater than. At your table group, explain how you know that 2 and 4/5 is greater than 11/4. You've now learned how to make use benchmark numbers with a number line. You've learned how to make common numerators, and you've learned how to make common denominators. Take a look at this one. 6.5 compared to 6 and 3/8. You can choose to use any strategy that you would like to. First of all, we know that 6 is the same, so we don't really need to pay attention to that part. If I want to compare 1/2 to 3/8, could I make the numerators the same?
Yeah.
1/2 is the same as 3 whats? Everyone? 3/6. So if I compare 3/6 to 3/8, what's bigger, 1/6 or 1/8? 1/6. So is 3/6 bigger or 3/8 bigger? So we can easily see that 3.5 is greater than 6 and 3/8. Yes? What if I want to make the denominators the same? I have 1/2 and 3/8. What denominator could I change it to? If I have 1/2 and 3/8, I have different units, right? What if I want to make the denominator the same? Could I make this into some number of 8s? 1/2 is the same as how many 8s? So again, we can see that 4/8 is greater than 3/8. Do you guys see that? Okay. What if I want to use benchmark numbers? 3/8, is that more or less than 1/2? But 1/2 is exactly 1/2. So again, we can use benchmark numbers. Do you guys see how using any strategy you get the same answer? Okay.